Let us now consider the mensuration of solid shapes. The first on the list is the cube. It has a uniform cross section of a square. So the volume is going to be the base area, which is L squared, times the height, which is L, and that will give us L cube. So we know the cube has 6 faces, as you can see. Therefore, the total surface area is going to be L squared plus L squared. So we have 6 of them. Next is the cylinder. This cylinder is also a prism with a uniform cross-sectional area of a circle. So therefore, it has a volume of base area, which is the area of a circle, times the height. It has a radius and a height. This cylinder can be opened at one end or both ends. That way we are left with only the curved surface area. Therefore, the total surface area of this cylinder will be the curved surface area plus the area of the two circles. So this is what we are saying. The total surface area of the cylinder is given by the area of the two circles plus the curved surface area, which is 2 pi r square plus 2 pi r h. And this gives us 2 pi r into bracket r plus h. Note that this cylinder can be opened at one end or both ends. So when it is open at one end, it is same as closed at one end. So it has a total surface area of pi r square plus 2 pi r h. That is when the cylinder is open at one end or closed at one end. Now let's take one example. A cylinder with base radius of 14 centimeters has the same volume as a cube of side 22 centimeters. Calculate the ratio of the total surface area of the cylinder to that of the cube. So we need to compare the volume of the two shapes or the two solids. So we have this pi r square h is equal to L cube. Then we do the substitutions to obtain this. We can now find our height, which is the h. So the h is equal to 121 over 7 or 17.29. Now we can find the total surface area of the cylinder using the formula 2 pi r plus h. Note that the question was silent. That means the cylinder is closed at both ends. Therefore, we use this formula to obtain this value for the cylinder. That is the total surface area of the cylinder. Then next, we obtain the total surface area of the cube using the formula 6L squared, and that will give us 2904 centimeters squared. Now we take the ratio. So the ratio is 19272 over 7 is to 2904. And we simplify this to obtain 73 is to 77, or 0.95 is to 1, or 1 is to 1.05. Another solid of interest is the cuboid, which is very similar to the cube. It has a volume of length times breadth times height, because all are not equal, and a total surface area of 2 length times breadth plus 2 breadth times height plus 2 times length times height. The triangular prism has 3 rectangular faces and 2 triangular faces. So the volume is still the base area times the vertical height. Then the total surface area is the total area of the net or the faces. So you find the area of the 2 triangles and the 3 rectangles, then add them together to give you the total surface area of the triangular prism. Let's take another example. The cross section of a rectangular tank measures 1.2 meters by 0.9 meters. It contains water to a depth of 0.4 meters. That's the height. If a cubical block of size 50 centimeters is lowered into the tank, calculate correct to two significant figures the rise in the water level in meters. So let's go. We have the volume of the tank before the block was lowered into it to be 1.2 meters by 0.9 by 0.4. So remember that the rectangular tank is the same as the cuboid. So the volume is given by length by breadth by the breadth by the height. So that's what we had over here, and it will give us 0.432 meter cube. And then the volume of the cubical block itself. Now this is a block of length 0.5 centimeters, and we need to convert it to meters, and that will be 0.5 meters. And the volume of a cube is L cube, and that will give us 0.125 meter cube. Now the next thing we do is to find the total volume, which is the addition of these two volumes to give us 0.557 meter cube. Then the next thing we do is to find the height from the new volume. So we know that our new height h times the length and the breadth should give us the new volume or the total volume now. And if you make h the subject, we get 0.5157 meters. Then we just have to subtract to find the difference in height. So we found the first height was up to 0.4 meters, and the new height is now 0.5157 meters. Hence, to find the difference in height is going to be the 0.5157 minus 0.4, and this will give us 0.12 meters, correct to two significant figures. Now a pyramid, unlike the prisms, do not have uniform cross-sectional area. Now, taking this pyramid for instance, it is a pyramid with a rectangular base, and this is the plan of frustum of this pyramid. Then the net is given by this. Now we can find the volume of this pyramid using the formula 1/3 times base area times the height. So the nature of the base determines the formula. Then find the vertical height. Then we use it to find the volume. And to find the total surface area, we'll find all the areas of the surfaces making up the net of the pyramid and sum them up. So let's take one example. We have OABCD is a right pyramid with a rectangular base ABCD. Its vertical height is OG. Then if AB is 6 centimeters, then BC is 8 centimeters, and each slant edge is 13 centimeters. So all these are 13 centimeters each. Calculate correct to 1 decimal place the vertical height OG. So we are finding OG. Then angle between a slant edge and the base ABCD, the angle between the triangle OAB and the base ABCD, then find the volume of the pyramid. Now from the diagram we know that AG is half of AC. So from here to here is half of this, that's the diagonal, half of the diagonal. Then by Pythagoras theorem we know that AC squared equal AB squared plus BC squared, but half of AC squared will give us the AG. So we have this formula. So AB squared plus BC squared square root will give us the length of AG. Now we sub in the values 6, 8 and simplify to obtain 5 centimeters. Next, we are supposed to find OG squared as the vertical height. So we know OG squared plus AG squared is equal to AO squared. And we're given these values, so we sub in to obtain something like this. Then we make OG the subject to obtain 12 centimeters. Now angle between a slant edge and the base ABCD. A slant edge and the base ABCD. Now let's take angle OAG. Angle OAG can be obtained using the ratio AG over AO. That is the cosine of this angle over here. So we know AG is 5, we found it over here, and AO is 13, we were told over here. So we simplify this expression to obtain 67.4 degrees. Now if X is the midpoint of AB, so we have something like this. X is the midpoint of AB. Then the angle between the faces OAB and ABCD can be obtained as follows. Let the angle be alpha. So this alpha over here. So this, we are using this line to represent the face OAB. Then tan alpha, tan of this angle will be OG over GX. Tan will be OG over GX as opposite over adjacent. And we know that from here to here is 8. So from here to here, which is the center, will give us 4. That is half of BC. So we have 12 over 4. Then we can solve this to find the alpha to be 71.6 degrees. The volume of the pyramid is given by 1/3 base area times height. That will give us 1 over 3 by 6 by 8 by 12. And that simplifies to 192 centimeter cube. Let's now talk about the cone, another pyramid. Now the net of the cone is a sector. Then also the frustum of a cone is a cone that is cut at right angles to the height at the tip. So this is how it will look like. Then the volume of this truncated cone is given by 1/3 pi into big R squared plus big R small r plus small r squared bracket close times the height, that's the vertical height over here. Then the volume of the cone itself is given by 1/3 pi r squared h, that is 1/3 the volume of a cylinder. Then we have the total surface area of a cone equal pi r squared plus pi r. So the base area is pi r squared and the curved surface area is this. Now one more thing we need to know about the cone and the sector is the relation between this and this. So if this is folded to form a cone, then the big R over here, that is the radius of the sector, is equal to the slant height of the cone. So big R is equal to L. Then the radius of the base of the cone, there's a relation between it. When we equate the curved surface area of the cone, which is pi RL, to the surface area or the area of the sector, we can simplify this to obtain R to be equal to theta R over 360 degrees. So that is the relationship among theta, big R and small r. And don't forget that L is equal to big R. That's why this will cancel out this, one of these. Now let's take one example. A sector of a circle with an angle theta is equal to this 800 over 11 and radius 21 centimeters. So if The sector is bent such that straight edges coincide to form a cone. Calculate, correct, to the nearest degree the vertical angle of the cone. So this is how we go about it. We know the radius of the base of the cone is obtained from the relation as we just saw. And then so now R, that's the radius of the base of the cone, is given by this. We sub in all these values to obtain 140/33. Then if y is the vertical angle of the cone, that is this whole angle here is y, then the angle that half of it will be the one over here in this right angle triangle. So sine y/2 will be opposite. So this is the slant height. So opposite over hypotenuse. Okay, so opposite is the small r over here over the hypotenuse, which is the slant edge, which is L. And don't forget that the L is equal to the R, that is the radius of the sector. So we sub in these values to obtain this. Then the next thing we do is to simplify this for y, and we obtain y to be equal to 23 degrees. What have we done so far? Nothing but one thing, and that is the volume of a cone is equal to base area times height. Total surface area is given by sum of areas of the net. Then pyramids, we have 1/3 base area times height. Then total surface area is given by sum of areas of the net of the pyramid. Then the volume of a truncated cone is given by this. Then also these solids can be evaluated for the volume using this formula, and total surface areas using this formula.